This video is a summary of the basic properties and syntax of using both views and functions in PostgreSQL. Basically, these can be applied in any database scenario, except that the syntax may differ from one platform to another. So to do this demonstration, we're actually going to use the Northwind database, the database that we've been using up until this point. And what I'm going to do is actually walk through the class exercise that we walked through already once before. And hopefully this will allow you to pause the video and go back and really analyze what's happening. So before we begin, I just want to note that I do have the ER diagram up in front so that I can use this as my guide in creating any SQL queries, views, or functions that I need to create. So on the top right here, I have my SQL editor, and if you'll see here, I'm logged into my instance of the Northwind database. Mine just happens to be called Northwind New, and I'm on my local host. So this is the SQL query editor. If you don't see this, you may need to go up into View and just select Default View. Sometimes the views get a little messed up. Also, I am not going to be stepping through the 5.1 assignment, since that kind of is a starting point for what we do in step 1 for 5.2. So if you understand how to do step 1 and 5.2, which is this assignment right here, then you should have no problem doing 5.1. So here we have our question at hand. It says, create a view that returns all orders by product. The view should return the following attributes: the product name, the company name, the order date, the quantity, the ship name, and the ship city. When I see this problem, the first thing I am tempted to do is come over here and look at my ER diagram. And in my ER diagram, I'll see a few things. Product name, which happens to be in the products table. Company name, which is in the customers table. Order date, which is in the order table. Quantity, which is in the order details table. Ship name, which is in the orders table. And ship city, which is also in the orders table. So right off the bat, just by looking up what attributes I'm trying to pull in, I figured out that I need to use the customers, orders, order details, and products table in order to get all of the data that I need to get. With that, I need to figure out how I can combine all of these tables together so that I am seeing a holistic view of the data, as opposed to data from customers versus data from orders versus order details versus products. To do this, we use joins. So let's start with products. If I go up here into my query window and I type select star from products, and I run this query, you will see that I get several pieces of information. Now, as we discussed already, I can alias a table name by simply putting a space after the name and then giving it a sort of a shortened name, or a nickname, or an alias. So for products, I'm going to call this P. And then the other thing I like to do is actually put the semicolon on its own line. This way I can add and subtract things a little bit more easily, and I don't have to worry about not having a semicolon. Up here, instead of star, as I had mentioned in previous lectures, the star is a dangerous shortcut that if you can avoid a star, it's usually a good thing, just because number one, it's a performance issue. Number two, it's a capacity issue. Number three, you don't need to use star. It doesn't scale well if table names change or if column names change. It introduces a whole new set of problems that you just don't really want to deal with. So just to avoid all of the problems, we try to explicitly state our column names. To do this, I can use my alias. Because we will be bringing in more tables into this query, I really want to be as specific as I can. And by specific, I mean when I grab a column or an attribute from a table, I want to explicitly state which table I'm taking it from and what the attribute name is. So in the case of this exercise 5.2 step 1, we actually want the product name. So I'm going to type P for products product name. And I forgot the dot. P product name. Now when I run the query, I only get the product name. The other thing I may want to do is I may want to order this product list. So let's just throw in an order by. And we'll order by the product name. And we'll make it ascending, which means that it'll start at A and work its way up to Z. And when I run this, you can see that now we have a product list that is in alphabetical order. The next thing we want to do is we want to now pull in the customers table, but we can't just directly pull the customers table in, because if you can see here, products and customers are not directly linked together. So we need to take on a series of steps to get there. The first thing is the direct link between products and customers. The first direct step is products to order details. Now we could have started at customers and then worked our way over to products, but in this particular example, we're going in the other direction. So if I want to bring order details in, I want to bring in all order detail records that have a product ID that also exists in the products table. To do this, I'll say join or inner join order details, and I'll call it OD, that's my nickname, order details on products P dot product ID equals order details dot product ID. The reason why I chose product ID is because that is the attribute that's in common with both. In products, the product ID is the primary key. In order details, the product ID is both the primary and the foreign key. In our particular case, it's acting as a foreign key. Now I have order details brought in. So from order details, we actually needed the order quantity, the quantity of the order. So why don't we just bring that in? And I do that just by going back up to my select. And now that I have order details named as a nickname, OD, I can actually put this in as my quantity. Now when I run it, you'll see something interesting happen. What's happened here is that if it is found in this query, it's found multiple records for an individual product. That's okay. The quantities are different for each of these because they're representing different orders. Now we actually want to bring in the order information. And to do this, I simply hit return after my first join and add another join. I don't need a comma or anything like that. I just simply type join. And this time we're going to join the next available table that is linked. So we want to join now order details with orders. So I'll pull in a new table called orders. Well, it's not new, it exists already, but I'll pull this table in. I'll call it O as its nickname, and I'm going to join this on OD, which is the order details right here, dot order ID, and only when it exists in both. So OD.order ID equals order.order ID. And for consistency's sake, let's put some information here. So we need from this order table, we need an order date, a ship name, and a ship city. So I can actually add these up here. So O dot order date, O dot ship name, O dot ship city. And we should get all of that information. And here it is. So here's our ship name, our order date, our ship name, and our ship city. Now I want to bring in the last table that's relevant here, which happens to be customers. So in this case, I want to get all customers that already exist in the orders table. So they have to exist in both. Therefore, I can use a join again. So join customers C, my nickname, on orders dot customer ID equals customer dot customer ID, where the customer ID in customer is the primary key and the customer ID in orders is the foreign key. And like I've already done before, I'm just going to put some more information up on the top, and specifically I'm going to put the company name because that's what I'm looking for here. Now when I hit run, I should get at the end of this whole long list, I'll get the company name. Now I have a query, which is great, but the assignment, step 1, is actually asking me to create a view. So I need to actually give this, create this as a view. And now that I have the query and I know that it works, I can simply go up to the top, say create view, give it a name. I like to precede my views with a V. So my view name will be V, and then something that is somewhat indicative of what the view is going to return. So select products, product orders by customer, or actually customer orders by product. Select customer orders by product. Now, unfortunately, in Postgres, case sensitivity does not exist, but we will just pretend that it does, just for clarification's sake. The other keyword that I'm missing here is just this as. So now I say create view, view name as, and then my select statement follows. Now, if I run this, I get a query result, query returned successfully with no result, which makes sense. All it did was create a view. And if I go to pop over to my PG admin tool, you'll see that if I click on schemas, right click, click refresh, my new view is right here. And if I click on it, you can see that all of the information is listed here. So I can recreate this view at any time. The next thing I want to do is I actually want to create another view. And based on the assignment here, you will see that it says create a view that returns the sum of all quantities by product. The view should return the product name and the total quantity ordered for each product. So to do this, we actually need to create another view. So I'm going to start the same way I started the first view. I'm going to, basically I'm just going to get rid of all of this for now because we already have a view. We don't need that anymore. And it's asking me to create a view that returns the sum of all order quantities by product. Well, since I already have a view, select customer orders by product, which is the view I just created, I can now use this data to create yet another view that actually gets all of the totals of each of the orders, each of the product orders. So in this case, I can say select star from a view, or I can say OBP, orders by product, is going to be my nickname here, and I can say OBP dot quantity and OBP dot what's the other thing we want? Oh, product name, right? So, and actually maybe I'll put the product name first just for readability's sake. OBP dot product name. Now if I run this, I get all my products by product quantities by product name. Now you'll see that there's actually a large number of them. So now what I need to do is I need to aggregate certain things. So the way that I can do that is by using a group by, and I'm going to group by product name, and I'll just say OBP dot product name, and if I run this right now it will fail, and I'll show you. And the reason why it fails is because you need to have a you actually need to have some sort of aggregation that's happening up in the select statement. And this is why it's giving us an error. You can't just group by something and not do something with that grouping. So in this case, we actually want to get the sum of the quantity for each product name. And to do that, we just use a built-in function called sum, and this should fix the problem. So now you can see that the multiple entries of the same product records have now been rolled up into one product line, and the totals have been gathered for all of the different orders that have been made based on each product name. So that is how we roll everything up. So it says it wants the total quantity and the name of the product, and I think we have that. So now we just need to give it a name and create it as a view. So we say create view v quantity or total quantity by product, and throw an as at the end, hit play, and you can see that the view is successfully created. And if I refresh my schema, that is my view there. Now if I run the view, and I'll just copy and paste here just because I'm getting a little lazy. And run this, that's what I get. So that's how I know it worked. We've created our two views. We can move on to the final step of the assignment for 5.2. The final step is actually to create a function that returns a count of the number of products that have orders greater than 10. Well, we kind of learned that the count for products of orders greater than 10 is everything, essentially. So we may want to actually modify this 10 to be something that's a little bit more realistic. So we're trying to get the number of products that have orders greater than 10, which implies that we actually need to know what the quantity by product is. And we created a view that actually does that for us. So we're going to open up a query window, a new query window, and I'll just minimize it a little bit just so that we can see the name of the views that we have. And I'm going to actually call the last view that we created. So I'm just going to actually make this a little smaller so we have two windows here. Close a couple of these windows so that we have a good view, into what we're doing here. Okay, so here are our views. I'm just going to copy this last view that we created. I'm going to copy the name, and that way I don't make any misspellings or anything like that. That might create a problem. So now I'm just going to call the view. Call the view by just saying select star from, and then the view name, which is our new view right here. And if I run this, you'll see that I get each of the different products and the total quantity that was ordered per product. So the question here now becomes, I want to find all of those products that have orders greater than 10. And by orders, we just mean the sum of the quantity here. So let's change that a little bit, and let's say, okay, we're going to select everything, and we may actually even want to change this everything, but for now let's just say select everything from this view where, and we're going to add a condition on it, and we could have said greater than 10, but why don't we say greater than 500, because right off the bat I see that this aniseed syrup is less than 500, so that should be taken off the list if we exclude anything less than 500. So we'll say where sum, and I get that column name by looking right here, where sum is greater than 500. And if I run this query, you'll see that the aniseed syrup, whatever that might be, is gone from the list, as are all of the other items that are less than 500, or 500 or less, I should say. So now that we've got something here, it's asking us, we'll reread, it wants to return the count of the number of products. So we have the list of products, but we don't really need the names and the values. We just need a count of how many products have order quantities over 500. So in this case, all we need to really do is say count. And if we run this, you'll see that we have 52. Now, this is a function. So when I call this function, I want to be able to get the value. So this is the bulk of the function, and we actually need to now enclose this into a function proper. And I'm just going to indent this, and you'll see why in a moment. So to create a function, we simply type create keyword and function, another keyword, and then we give it a name. So we'll say that this is total products over 500, or total products, we'll just say. And this function, because it's a function, has parentheses after the name. Now we want this function to actually return something to us, and so we use a keyword returns, sorry, forgot the S, And we want to return something that is, in this case, an integer, because it's going to be a number. And we're going to call this integer, we're just going to give it a nickname, if you will, or a variable name. And it's surrounded by the $signs just to tell the interpreter, the SQL interpreter, that it needs to treat this particular word in a special way. So now that we have our return statement, we now need to figure out how to assign the value that's going to be returned so that anytime I run this, it'll return whatever the value is, regardless of whether or not, regardless of what the code is inside. So to do that, we need to declare a variable, and we're going to declare the variable called var_total, and we're going to declare it as an integer because that's what we want it to return itself as. And lastly, we need to tell it where the actual bulk of the work is going to be done. We do this by typing the word begin, then we put all the work that we want to complete within the function, and then when we're done, we type end. And end will allow us to allow the compiler to actually figure out that it's done, and it will exit out of the function. Now, we have this variable, but nowhere is the variable actually being assigned any kind of value other than a data type, which is integer. So in order to assign the value to the variable, we need to actually select the count, the number 52 that we got here, and we need to assign whatever this number is to the variable. And to do that, we can say select into and then the variable name, just like that. So it's pretty simple. And now that the variable has been assigned, we actually, because you need to be very explicit, we actually have to tell the function this is the value that we want to return now. So we use the keyword return, and then we give the variable name that we're actually sending back as our return value. And I spelled total wrong, so it would have failed. Now you'll also note that the SQL statement, the select statement, is followed by a semicolon, as is the return. So these are technically two different statements that are happening, but because they're inside the begin and the end statements, they're treated in a special way. Now the last thing we want to do is we actually want to just put a line here just saying that we are using PostgreSQL. Sorry, I'm looking for the G on my keyboard. And that's how we want things to be returned. I don't know if this is a full-fledged requirement, but in order to follow this format of setting up a function, you, I believe, are required to do that. I haven't actually tried not doing it. So you're welcome to try that as well. So now I'm going to run this. And it looks like I used the wrong variable here. So let me, there we go. I named the variable incorrectly. So now this should work. Perfect. So now return successfully with no result, which is fine. If we pop back over here to our pgadmin tool and refresh our schema, you'll see that now there's a function called total products, and there it is. Now to call this function, I can simply type, and I'll open a new query window just to kind of keep things separate. I can say select and then give it the function name total products, and this should return a 52, which it does. Now, if I changed this to something other than 500, then I could certainly, rerun the program. So let's say I said 600. I would have to actually change this create to be create or replace, because now the function already exists. So I'll get an error if I just try to recreate it without deleting it first. So in this case, if we put or replace in the create statement itself, that lets the interpreter know that you're actually, if it already exists, remove it and start all over again. So if I run this now, and then rerun the total products, I may in fact get a different value, and I did. So only 44 products have a total of, or a sum of 600 or more, actually more than 600 products, product quantities. And that is simply how we do a function.